Hello friends, myself Chetan Sir. I am master teacher here at Vedantu. I welcome you all again to our RMO Flashback series. Right, in today's session we will be discussing question 3 and question 4 of year 1992. Right, and in fact we will discuss 4 methods to solve question 4, which was a geometrical question. Right, and we will see a little simulation of that question right in a video. Right, so let's start our session. Right, and before discussing this question 3 and question 4, I'll give one information to you people. Right, currently here at Vedantu we are running pre-RMO, RMO and INMO batches. Those who have not appeared for pre-RMO yet or who have not cleared pre-RMO exam yet, they can simply visit our website olympiad.vedantu.com, and those who have already cleared pre-RMO or RMO, we will directly enroll you to RMO and INMO batches. Right, those who have cleared pre-RMO, we will enroll you to RMO batches, and those who have cleared RMO, we will directly enroll you to INMO batches. And all these courses are totally free of cost. You do not need to pay even a single rupee to enroll in these batches. All you need to do is just mail me your name, class, your proof that you have cleared either of pre-RMO or RMO, along with your contact number and address on this email ID, right? chetan.garg@vedantu.com. Okay. The batches are free only for those people who have already cleared pre-RMO and or RMO exam, right? We will enroll you to respectively RMO and INMO batches, right? So let's start our session. Let's discuss question number 3 of year 1992, right? So that was an easy question. The question says that we need to determine the largest 3-digit prime factor of the integer 2000C 1000, right? So basically पहले हम ये देखते हैं कि 2000C 1000 का मतलब क्या है, right? तो 2000C 1000, this is nothing but this is actually equals to 2000 factorial upon 1000 factorial into 1000 factorial, right? So obviously NCR is always a natural number, right? तो अभी हमें ये देखना था कि which is the largest 3-digit prime number which is divisible by this, or we can say what is the largest 3-digit prime factor of this number, right? Or of this number, ठीक है? तो if you clearly see that 2000 factorial will be nothing but 2000 into 1999 into 1998 into and so on till 1001, right, into 1000 factorial upon 1000 factorial into 1000 factorial, right? So this 1000 factorial got cancelled out with this, so we are left with only this number, right? तो अब हमें ये फाइंड आउट करना था कि व्हाट इज द 3-digit नंबर दैट इज डिविजिबल बाय दिस, ठीक है? लार्जेस्ट 3-digit नंबर, लार्जेस्ट 3-digit प्राइम नंबर, ठीक है? तो बेसिकली वो प्राइम नंबर ऐसा होना चाहिए जो 1000 फैक्टोरियल में तो एक ही बार आए, राइट, एंड इसमें 2 बार आ जाए, ठीक है? जो ऊपर हमारा न्यूमरेटर है, राइट? जैसे एक सिंपल से एग्जांपल, जैसे लेट्स से वी टॉक अबाउट नॉट अ प्राइम नंबर, लेट्स डिस्कस अबाउट अ नंबर 600, ठीक है? 600 comes one time in 1000 factorial, right? If we write 1000 factorial, it will be 1000 into 999 into 998 and so on, ठीक है? तो 600 number will appear only once, but its multiple, that is 1200 and 1800, it has got 2 multiples which will appear in the numerator, right? But obviously 600 is not a prime number, and in fact बाकी सब combinations करके हम 600 बना तो सकते हैं, but independent 600 number and its multiples वो 2 बार ऊपर आ रहे हैं ना, एंड एक बार नीचे आ रहे हैं डिनोमिनेटर में, राइट? तो अगर ऐसा कोई प्राइम नंबर होता है, लेट्स से एनी प्राइम नंबर जिसके 2 मल्टीपल न्यूमरेटर में हो, राइट, एंड ओनली एक ही मल्टीपल, मतलब वो खुद प्राइम नंबर नीचे हो, ठीक है? देन इन दैट केस एक मल्टीपल उसका डेफिनेटली बच जाएगा, ठीक है? तो द लार्जेस्ट 3-digit नंबर विच वी कैन पुट लाइक दिस इज 666, because 666 into 3 is 1998, right? And its one multiple will be 666 into 2, right? Now if we think about 667 into 2 will definitely be in the numerator, but 667 into 3 is nothing but 2001, and this will not appear in the numerator, ठीक है? So I hope अभी आपको समझ में आ गया होगा. What we need to find here is a prime number which is closest to 666 and less than 666, right? तो 666 is छोटा prime number. Okay, 665 will not be a prime number, right? 664 again will not be a prime number. 663 is divisible by 3, so it will not be a prime number. 662 is an even number and it will not be a prime number. 661, right? So if you check 661, this will come out to be a prime number. So our answer to this question is 661, right? Why? Because in 1000 factorial, 661 will appear only once in the denominator, right? And in numerator, it will appear two times, one in 661 into 2 and the other one in 661 into 3, right? So 1661 obviously got cancelled out, but still we are left with 1661, right? So the largest 3-digit prime factor of this number will be 661. ठीक है, तो आई होप ये वाला क्वेश्चन क्लियर हो गया होगा. काफी आसान सा क्वेश्चन था. ऑल यू नीड टू डू इज जस्ट आपको एनसीआर का मतलब पता होना चाहिए था. आफ्टर दैट ये एक जस्ट कॉमन सेंस पे बेस्ड क्वेश्चन था, राइट? सो लेट्स प्रोसीड विद द नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 4 ऑफ ईयर 1992. तो ये एक ज्योमेट्रिकल क्वेश्चन है जैसे कि आप देख सकते हो, एंड इनफैक्ट ये काफी आसान क्वेश्चन है. इनफैक्ट अगर हम लेट से बात करें, ऑल यू नीड टू डू इज जस्ट टू नो पाइथागोरस थ्योरम टू आंसर दिस क्वेश्चन. बट यस, दिस क्वेश्चन हैज गॉट सम इंटरेस्टिंग सॉल्यूशंस आल्सो, राइट? तो आज हम इस क्वेश्चन के कुछ 4 डिफरेंट सॉल्यूशंस डिस्कस करेंगे, राइट? एंड एक हम ज्योमेट्रिकल सिमुलेशन भी देखेंगे, राइट? एक वीडियो वॉच करेंगे 1.5 मिनट का, जिसमें ज्योमेट्रिकली आपको समझ में आ जाएगा कि ये कैसे 4r² के इक्वल आ रहे हैं, राइट? So let's study this question. And the question is saying that ABCD is a cyclic quadrilateral, right? With the diagonals AC and BD which are perpendicular, right? And the point of intersection of the diagonals, that is AC, meets BD at E, right? Now what we need to prove? We need to prove is EA square plus EB square plus EC square plus ED square, that is nothing but 4R square, right? So let's first draw the figure. Let's say this is ABCD, right? This is a cyclic quadrilateral and its diagonals are perpendicular, and this point of intersection is nothing but point E, right? So this EA square plus EB square plus EC square plus ED square that we need to prove is 4R square, right? So let's first discuss the common solution जो most of the बच्चे करते हैं, right? Let's assume ABCD is a cyclic quadrilateral and these diagonals are perpendicular, all right? And let's say this is the point of intersection E. Let's assume the center of the circle is O, right? And let's say this point is M. Okay, let's assume this point is P, and let's assume this point is Q, right? Okay. So since where OP is nothing but perpendicular and OQ is nothing but perpendicular on BD, right? Clearly if 3 angles are 90 degree, this angle will also be 90 degree, ठीक है? And we know अगर हम सेंटर से किसी भी कोड पर परपेंडिकुलर ड्रॉ करते हैं, then it will bisect the chord. So that means AP will be equal to PC, and similarly this DQ, that will be equal to QB, right? So let's assume this AC, that is nothing but 2M. Why 2M? Because that will imply AP will be equal to M, right? And let's assume this thing, which thing? BD, like, right, BD to be equals to, let's say, 2N. So that will imply BQ, that will be equal to N, right? Let's assume this PO to be equal to X, right? PO equals to X, and this OQ equals to Y, right? And this OQ equal to Y, right? So this will imply PO will be same as EQ, right? So EQ will be nothing but X, and this EP will be nothing but Y, because why? Because this OPEQ is a rectangle, right? ये हमने कंस्ट्रक्शन से बनाया, राइट? दिस इज अ रेक्टेंगल, राइट? आई होप यहाँ तक कोई इश्यू नहीं है, एंड दिस इज द कॉमन सॉल्यूशन जो बहुत सारे बच्चे करते हैं, राइट? सो ऑल वी नीड टू डू इज नाउ कैलकुलेट EA स्क्वायर प्लस EB स्क्वायर प्लस दिस EC स्क्वायर प्लस ED स्क्वायर, राइट? तो व्हाट इज EA स्क्वायर? EA is nothing but AP plus PE, right? EA is nothing but AP plus PE whole square, right? And EB is nothing but EQ plus QB or BQ whole square, right? What is EC? EC is nothing but PC minus PE, right? PC minus PE whole square, right? This is EC, right? And what is ED? ED is nothing but, you can say, DQ minus EQ whole square, right? Okay, all right. Now plug in the values. The AP was M, right? So this is nothing but M plus Y whole square, as you can see, right? So EQ is EQ. Okay, EQ was X and QB was N, right? BQ was N. So X plus N whole square plus PC will be M, AP is M, and that will also be equals to PC, right? Similarly, BQ is N, and that will also be equals to DQ, right? So PC, that is PC was M minus PE. PE was nothing but Y, M minus Y whole square, right? Plus similarly DQ is nothing but N minus EQ is nothing but X whole square, right? Now if you open up these whole squares, this 2my, which one term will be there, and there will be minus 2my, that will got cancelled out, and again here there will be one term 2nx, and that will cancel out with this minus 2nx. So all we are left with twice of m square plus what you say, m square plus n square plus x square plus y square. That is what we were left with, right? So as you can clearly see, this BQ square, right? Let's say BQ square plus what is this, OQ square. That is nothing but BQ was how much, n square plus this OQ was y, right? N square plus y square, that is nothing but OB square. That will be the radius of the circle, right? So that will be r square. Similarly, you can say this m square plus x square is again r square. So what we got this is nothing but twice of r square plus r square, which is nothing but 4r square. That we need to prove, right? So this is one method, and in fact this is a very common method to prove this question. Almost every student of let's say up to 8th or 9th or 10th standard generally does this question by this method, right? And so I hope ये वाला method समझ में आ गया होगा. Now let's move to one more solution of this question. ठीक है, how we can do this by just simply making some construction. Okay, so that this is nothing but this is method 1. Now let's move to one more method of this question. We will call it as method 2, right? So this is a very easy method. Let's say ABCD was our cyclic quadrilateral, and E was point of intersection, and that was perpendicular, right? Now what we have made a construction. Let's draw AF parallel to BD, right? So we have drawn AF parallel to BD. So clearly, since AC was perpendicular, to BD, so we can say this will imply angle CAF will be equal to 90 degree, right? Because AF and DB are parallel, right? And since angle CAF is 90 degree, so this will imply CF will be the diameter. CF is diameter. I hope ये बहुत आसान है, क्लियर हो रहा होगा, है ना? And since CF is diameter, so this will further imply angle CBF, that is equals to 90 degree, right? Right. So we can say this CB square plus this BF square, that is nothing but CF square, which is diameter square, which is 2r square, which is nothing but 4r square, right? So what we have got CB square plus this BF square, that is equals to 4r square. तो आई होप अभी काफ़ी बच्चों को फील आ रही होगी, है ना, कि शायद हमें कुछ यही प्रूव करना था, राइट? 4r स्क्वायर तो हमारा आ गया, बट हाउ दिस CB स्क्वायर प्लस BF स्क्वायर इज इक्वल्स टू दिस. ठीक है, लेट्स सी दिस. This was the point E, right? So can you tell me what will be EA square? Okay, plus this ED square. That will be nothing but that will be AD square by Pythagoras theorem only, right? And similarly, can you tell me what will be this EB square plus EC square? That will be again by Pythagoras theorem. That will be nothing but CB square, right? So actually we need to prove that this EA square plus EB square plus EC square plus ED square, that will be equal to 4R square. That we need to prove, and we have already proved this thing, right? So as we have done this, EB square plus EC square, that will be nothing but how much? BC square, and the sum of these two will be nothing but how much? AD square, and that is equals to 4R square. So all we need to do is we need to prove that this AD square, that should be equals to this BF square. These two should be equal. If we will be able to prove this, then I guess we are done, right? And this is pretty easy. Why? Because AFBD is a trapezium, and in a cyclic quadrilateral we can only make an isosceles trapezium, because sum of opposite angles are also 180 degree, and these two are parallel, so sum of these two angles are also 180 degree. So this will imply that this angle will be equal to this. That means these are isosceles triangle, and this will simply imply that AD is nothing but AD is equals to BF. So I guess we are done. Okay. So this is method 2, in which we have again proved this to be equal to 4R square by simply just making some construction, right? Right. So chalo, now let's move to a next method, method 3. Okay. So this is method 3 for this question, right? Again, let's say this AB CD was a cyclic quadrilateral with E as its point of intersection, right? Right. And okay, now let's consider this EA. Let's assume this EA to be small a, right, and EB to be equals to small b. We have assumed these numbers, right, to make just the calculation easier, right? ED equals to D, and what is left? EC, that is equals to C, right? So all we need to prove, that is A square plus B square plus D square, A square plus B square plus D square plus C square plus D square, okay, that is equals to 4R square. That we need to prove, right? चलो देखते हैं अब इसको. Let's consider, if you consider a triangle ABD, right? Consider a triangle ABD, and we know we know the formula of circumradius, that is capital R, that is nothing but ABC, that is AB into BD into AD. These are the sides of the triangle, right? ABC upon 4 delta. Delta is area of the triangle. What will be area? Area will be nothing but half into base, that is BD, into height, that is AE, right? So what we have used the formula of circumradius, that is nothing but ABC upon 4 delta, where ABC are the sides of the triangle and delta is the area of the triangle. I hope ये formula आपको पता होना चाहिए if you are preparing for RMO, right? So BD got cancelled out with this BD, and capital R is nothing but that is equals to, okay, AB. What is AB? AB is nothing but EA square. All right, that was A, that was small b, that was C, and that was D, right? So AB is nothing but under root of how much? A square plus B square, right, into AD, and AD was nothing but under root of how much? This A square plus D square. All right, right. So this got cancelled out with this 2 upon AE, right? AE was nothing but A. Okay. So there is 2 in the denominator. Let's say we take 2 here, right? Multiply this 2 here, right? Now let's square these things. What we will get? 4R square, that is equal to, these two will got multiplied, A power 4 plus A square B square plus this A square D square plus this B square D square whole upon A square, right? As you can see, in the first 3 terms A square got cancelled out. So what we will get 4R square that is nothing but that is equals to a square plus b square plus d square plus this new thing bd upon a square, right? In fact, which we need to prove now is that is nothing but that should be equal to c square. And in a circle we know that this a into c, that will be equal to b into d, right? Or you can simply prove this by similar triangles, right? This is a common fact that in a circle, if two chords intersect at a point, then the product of these segments are equal, right? So a into c is equals to b into d, so that will imply c is nothing but bd upon a. So, right, so plug the value of this c here. So what we will get 4r square equals to a square plus b square plus c square plus d square. That is in fact what we need to prove, right? So that was our third method to prove this question. I hope ये समझ में आया होगा, right? इसमें कुछ construction भी हमने नहीं किया है, right? But all we need to know is this formula: capital R is equal to ABC upon 4 delta, and one common fact that product of these two segments are equal, right? Chalo, now let's proceed to a fourth method of this question, right? In this method we will use a little bit of trigonometry, right? So let's assume these this was a cyclic quadrilateral, right? So this was the point of intersection E, and in fact this angle is 90 degree, right? So now if you consider triangle ABC, right, what you can say, we can say that AB upon this sine of AB upon sine of opposite angle, right? That is sine of angle ACB, that will be nothing but 2r. That was sine rule, right? I hope ये आपको सबको पता होगा. Sine rule was a upon sine a, that is equals to b upon sine b, that is equals to c upon sine c, and that is nothing but twice of circumradius, right? That is a sine rule that you should know, right? So ab upon sine of angle ACB, that is equals to 2r. Okay, so we can say that this AB, that is nothing but 2r sine of angle ACB, right? Now if you consider triangle, which triangle? Triangle DBC, right? Triangle DBC. We can say that this CD upon which sine of angle CBD, right? That is again nothing but 2r, because circumradius is same for both the triangles. That will imply CD is nothing but 2r sine of this angle CBD, right? And if you clearly see that angle CBD plus angle ACB, these are nothing but that they are complementary angle, right? Because this angle was 90 degree, right? So if we square and add these two things, right? Let's say if we square and add these two things, what we will get? AB square plus CD square, that will be 4r square, and this is nothing but sine square theta plus this will become cos square theta. Why? Because the angles are complementary, right? So we will get simply 1, right? And AB square is nothing but EA square plus this EB square, right? And what is this CD square? CD square is nothing but this EC square plus ED square, and that was nothing, that is equals to 4r square, right? So very easy question if you use a little bit of trigonometry along with the sine rule. Okay, so we can simply prove this to be equal to 4r square. Okay, so I hope if for all methods are clear to you. Okay, all the 4 methods. Now let's see a little simulation of this question. Okay, that I found on one channel of YouTube. I guess the channel name was Think Twice, right? So let's see a simulation that is basically exactly the same question, right? All right, this is a circle, right, in which two chords are perpendicular, right? Let's assume these are the two perpendicular chords which meets at a point E, right? Now we need to prove that EA square basically is a square that we can form on this segment. Let's assume the individual sides EA, EB, EC to be A, B, C, D. Now EA square will be this square, and similarly let's plot all the other squares, EB square, EC square and AD square, right? Now if we calculate, if we add these all areas, what we actually got, we got this, we got a square whose side is nothing but equal to diameter, which is 2r, right? So geometrically this seems to be equals to 4r square, right? This is a simulation. Now let's see what happened exactly. Okay, so ea square plus eb square, that is nothing but this thing, a square plus d square is equals to this, the hypotenuse, right? And now if you rotate this by some angle, let's say by 9, right? So these two will be perpendicular, and what we got, a square plus b square plus c square plus d square, that is nothing but that is equals to the diameter square, right? Right, so that was the simulation, that was the result, a square plus b square plus c square plus d square, that is equal to diameter square, which is nothing but 4r square, right? So all right guys, that's it from my side for today's session. We have discussed question number 3 and question number 4, and again before ending I'll announce once again that currently here at Vedantu we are running pre-RMO, RMO and INMO batches. Those who have already cleared pre-RMO or RMO exam, they will be directly enrolled to RMO and INMO batches respectively, right? All you need to do is just mail me your name, class, contact number and address along with the proof that you have cleared these exams on this email ID, right? chetan.garg@vedantu.com. We will simply enroll to you to the respective batches, right? So see you in the next session. In the next session we will be discussing next two questions of year 1992, right? Okay, thank you, bye bye.